Today our discussion is going to be on ellipses. Really, what is an ellipse? It's a flattened out circle. So we're going to have two standard forms. One of them is going to look like an ellipse that is like this, that is flattened in the x direction. And instead of having a center and having equal distance around the center, our distances are going to be different. So what are our important points of an ellipse? So first of all, an ellipse will have a center. The center is going to be identified as HK, just like the circle. But on an ellipse, there's going to be, our standard form is going to be 1 on the right-hand side. And then whatever number is underneath the x variable is going to be the direction that you move in the x direction from the center. So A is the distance from the center to what we call a vertex. So let me draw that. So the distance from the center to a vertex is called A, and we're going to go in A in both directions. So an ellipse has what we call two vertices, and in this ellipse, whatever this number is, we're going to move in the direction of y because it's underneath the y, and B is the distance from the center to what we call the co-vertices. Let me draw that in my picture. The distance from the center to the co-vertice is going to be here, and then we go both the B directions in both directions to get our co-vertices. So just take down those notes on the back of your 9-2 examples. There's two types of ellipses. This is the first type. And the second type of an ellipse we can have is a circle squished in the y direction. Okay. So as far as looking the same, we'll still have an H and a K for our center. A, however, will be the direction that we go from the center to the vertex. So A is going to be the distance in the y direction, and we'll go down A. B is going to get us to our co-vertices. So try to label all these points on the blank side of your notes, and then I'll show you a couple examples to draw your ellipse. Okay, so let's take an example of this first problem number 1. And we can see that, again, like the circle, there's no points but the x and y. So our center is going to be at 0, 0. So let's graph that point. And then these numbers underneath represent what direction we go. So if the number underneath the x, this is the direction we're going to go in the x. And we don't move 25, but we actually move the square root of this number. So we're going to move, since it's underneath the x, we're going to move 1, 2, 3, 4, 5 in the x direction, both positively and then negatively. Since 36 is underneath the y, this tells us which direction to move in the y direction. And the square root of 36 is 6. So we're going to move up 6 and down 6. And we connect these 4 points as smoothly as we can. And how do I know if I have a vertical or a horizontal ellipse? Write yourself a note. A in an ellipse is always largest. So A is the distance between the center and the vertex. So these would be your vertices. The smaller side will be your co-vertices. So Today, all you need to do is label these. When it says identify the vertices and the co-vertices, I want you to get practice of knowing where they belong. You don't have to state them in a point yet. So let's try number 2. Again, we have a center at 0, 0 because there's no x and y. 36, move in the direction, in the x direction, not 36, but the square root of 36, which is 6, and going to the right and to the left. And this is going to be a little skinnier ellipse because we're going to go in the y direction, 3, because the square root of 9 is 3. Okay. Connect your points. To draw an ellipse, it's almost easier because you don't have to be perfect than in a circle. As far as identifying, remember the longer side are your vertices, your shorter sides are your co-vertices. So in 5 and 6, it's a little bit more advanced, but it's advanced because we don't have our center at 0, 0. So how do we know how to label our center? This has no x coordinate, so it's not nothing, but it's 0. Like the circle, if it's a minus, it's really a plus. So let's graph the circle. 0, 2 is here. This is the center. Okay, and now let's look at these numbers. I'm going to move in the x direction. Oh, this isn't very pretty, but I'm going to move in the x direction, not 40, but the square root of 40. Whoops. So square root of 40. I'm going to move in the x direction, 6.3. So I'm going to move in the x direction, 1, 2, 3, 4, 5, 6, and a little bit more. Why the x direction? Because this number is underneath the x. Oh, square root of 15 is not pretty either. It's a little bit less than 4. What is it exactly? 3.87. So we're going to go in the y direction, 1, 2, 3.8, and 1, 2, 3, almost 4. Remember we moved, what did we move there? Square root of 40, which is 6.3, and we'll move 1, 2, 3, 4, 5, 6, and a little bit more in the x direction. Connect your 4 dots, and then let's decide where we're going to put our co-vertices and our vertices. How do we know? This is 6 point something, and this was 3 point something. So this is larger, so these would be our vertices, and these would be our co-vertices. Try number 4, and then I'll see if you're correct. A couple things going on here. X has a, remember when it's minus, it's really plus, and when it's plus, it's really minus. So the center is at 2, -5. We go in the x direction, 4. I don't know if you see this number under here. Put a number under there. It's a 1, so we're going to move in the y direction, 1 and 1. What is the longer side? 4 is definitely longer, so this would be a vertice and a vertice. These would be my co-vertices. Problem number 6. 5 and 6 are similar. See if you can graph them, and then when we come into class together, I will define for you the major axis and the minor axis. Try some of the problems of graphing on your worksheet, and when we get back together, I will give you these definitions.